So let's get busy. So let's put our homework away. We're not doing homework now. We are doing learning our stuff so that we are able to do the homework. All right, here we go. Are we ready for number or letter F? All right, here we go. X squared plus 9 greater than 6x. We're going to solve this guy. Suggestions?
Move 6 over.
Move the 6x over. Good idea. Then what? Factor it. And is this another one where the two factors are the same? So it doesn't matter how you write it. It doesn't matter how you write it. Either way is fine. This way with the separate factors, this way with one. On the number line, there will only be one dot. Would you agree with me? Because the parentheses are the same. And it will be an open dot. And because it's a weird problem, because we have two factors that are the same, we can't do the alternating, can't do any of that stuff. We have to pick numbers and actually try it. So, what would be a number over here?
4.
4. So you can put 4 in here. Actually, you can put 4 in anywhere. It doesn't matter. I'm going to go and put it in here because it's going to be easier. If I put in 4, I get 4 minus 3 squared, which is 1. Is 1 bigger than 0?
Yes.
Okay, so this works. Okay. Now, pick a number over here.
2.
2. Put 2 in anywhere you want. 2 minus 3 is negative 1, but I'm squaring it, so it also is positive 1. So that works also? I don't know. You tell me.
No, it's
I see some people shaking their heads. It's not everything, is it? Because why? The 3's not included. So, it's not nice. It's going to be a union problem. It's going to be everything from negative infinity to 3. Union with everything from 3 to infinity. So even though it looks like it's everything, it's open right there. Now, what if this had had an or equal to on it? Then it would be everything, because that or equal to would color in that dot. But we don't say all real numbers, we would say negative infinity to infinity, right? Huh? What are you grinning about? You're just happy to be here on a Friday afternoon. Yep, there we go. All right, number 3. Now we're going to get our calculators out. And we're going to solve this on our calculator. So, what we have been doing these last few problems is what we call solving algebraically. We've done it without a calculator. Now we're going to do it with a calculator. Okay? Now, I've been doing all kinds of weird things today on my calculator. So I'm going to go ahead and zoom 6. All that does is bring me back to a normal setup. You may already have a normal setup. You may want a different setup. I don't care. Taking a deep breath because I'm getting ready to explode. Because there are too many people that don't have calculators out. Elijah, where's your calculator?
I just have to buy like a new charger.
Okay. We have to have a calculator. Okay. So I don't know what the holdup is, but fix it. All right, we gotta have one. Who else do I need to yell at? Do I need to yell at anyone else? Elijah's the only one that needs yelled at. These all have batteries, they're functional.
Yep.
You have a calculator? Couldn't see it, yeah. You got a calculator? All right, so now I want you to type in, we're gonna graph this equation. So hit y equals, and type in that equation. 4x squared minus 12x plus 7, and hit graph. Anytime you graph an x squared, it's going to be a parabola of some kind. You see something that looks like that.
Yep.
Now, last time we did these, it was an equation. It was an equal 0. And when it was an equal 0, we were looking for these 2 points right here. You remember that? We are still looking for those 2 points. But now, we want everything below those 2 points. So the answer is going to be that little section right there because it's underneath those points. Okay? So let's find them. Second calc 0. Left bound needs to be over here somewhere, anywhere. Right bound needs to be down here somewhere. Right bound needs to be down here somewhere. And then put it close to that point in that general vicinity. Tell me what you got right here. 0.793. So one boundary of our shading is 0.793. All right, let's find the other one. So second calc 0. Now my left bound needs to be over here somewhere. And my right bound's up here somewhere. Jeez. Yeah, what'd you get for that one? 2.207. Oh, I want to say something. I don't know whether your calculator did this or not, but mine says x equals this, and then it says y equals this. Does anybody else say that or just mine? Okay. Now, this is going to happen periodically. This is scientific notation times 10 to the negative 12. Tell me about a number that's times 10 to the negative 12. Big, little?
Very little.
Very.
Pretty much 0.
Pretty much 0, exactly, Sam. So when you see this on your calculator, something like that, it's 0. It's 0. There's a little bit of round off error in there and the calculator's sensitive and picks it up. That's 0, right? No confusion. When that pops up on any problem anywhere, that's 0. So what's my answer? Well, these are open dots. And I need to be in between them. So 0.793, comma, 2.207. Is that okay with everyone? Perfect. Perfect, perfect. Do you feel like you and your teammate can do these? All right, go for it.
All right.
Minus 1. Yeah.
Let's go with the thousands. That's what the E does, so we'll see how we see with that.
Wait, if you bracket it, since it's going the other way. Oh, wait, never mind.
And it says greater than, so it's equal to other,
Wait, hold on. What?
236.
so the lowest can be 0.6.
Okay, how are we coming? Are we getting these zeros right here? All right, now we gotta answer the question. Remember what the question is. Where are we above those points? So wouldn't that be all of this and all of this? So, what is my answer? Negative infinity to negative 236, beautiful, or 4.236 to infinity. You guys are amazing, that's exactly right. Remember, we're graphing x values. These are x values. So all of the picture over here, so negative infinity up to that point, and then that point on. Perfect. What's different about C?
Here's a 3.
It's a cube. Now, we're still gonna do everything exactly the same, but the picture will not be a parabola. It's going to be some funky shape. So, it isn't in descending order, but the calculator doesn't care. So you can go ahead and type that equation in just like it is if you want. And remember, to get x cubed, you can use that button right there, that caret button. And we got a classic cube shape. It's a squiggly. Cubes are squigglies like that. That's what cubes look like. So there are 3 x-intercepts or 3 zeros. Right? So here we go. Find them. Listen, I know you just want to get out of here, but time goes faster when you're busy.
That is true.
Yeah, I was confused. They run
How do my points look?
Good. Great, actually.
All right. So remember, we are looking for where the curve is less than 0, so underneath. So that would be this section of the curve and this section of the curve, right?
Yeah.
Yeah, you got it.
So our answer will be
Negative
2.060, comma, 0.125, union 1.934, positive infinity, going that way, positive infinity.
Even if it's like going down.
Okay, remember, we're looking at x values.
Oh.
We're graphing x
You
values.
care about y.
We don't care about y. We care about y. We're looking at x values. And when you're on this side of the number line, you go to the positive infinity. All right, one more. Oh, back to a parabola. One more, and then we're gonna do some word problems. You can, we're doing it graphically.
Oh, so you don't factor then graph?
Yeah, it wouldn't hurt anything, but what a waste of time. Right, it absolutely could, it absolutely could factor it, and the graph is gonna look the same.
The graph just takes care of the graphic part, or the.
You don't need to factor when you graph it, but you could. All right, I only got 1 0 this time, and I got it at -2/3. Did you get repeated sixes? So remember that fraction is 2/3. -2/3. Is that okay with everybody?
Yeah.
Now wait. Our answer is, that's a solid dot this time. And our answer is where the curve is above that dot.
Above or equal.
Yeah, above or at it. So tell me about that. Ready? It would be everything, that's exactly right, because the whole shebang is above. Everybody good with that? Now, what if this sign had been a less than?
And it would be -2/3.
No, it'd be no solution. It would be
No
no
solution.
solution. Everything's
Because
above.
nothing is below, right? If you have less than, nothing is below. So that would be empty set. This would be empty set, no solution. Is that all right? All right, number 4. Projectile motion. Who do I have that's a physics student in here? Somebody in here takes physics?
Here.
Right there?
Huh?
You'll recognize this. I'm not gonna ask you for your insight or anything, but you'll recognize this. This little formula right here is what we call the projectile motion formula, okay? You do not need to memorize it. I will provide it to you if I want you to do, which I will, once you do a projectile motion problem. What you need to be able to do, this is like the general formula. You need to customize it for your particular problem, okay? So to do that, we need to know what all this means. This is the same as height. That is the height at time t. So this is like the y, f of x, only it's s of t. This is like your y, your height. The -16t squared is going to be part of the equation all the time. Jake, do you know, except for what? When is that not -16?
When it's starting at a different.
No.
I cannot.
Okay, that's all right. If we're doing our problem in feet,
I remember that.
we're doing our problem in feet. If we did it in meters, there would be a different constant there.
Oh,
But we're doing it in feet, so that -16 is going to be the same in every feet row, okay? Jake, you know what this means. What's this mean? Not any velocity, but the initial velocity. This is called V sub naught, and that is my initial velocity. And then S sub naught is my initial height. My feet, yeah. My initial number of feet. Okay? So when I read the problem, okay, I'm going to write an equation for this data. A projectile is launched straight up from ground level with an initial velocity of 256. So I'm going to put 256 t. And what is my initial height? Why?
You start on the
Yeah.
That's right.
Unless you're safe.
I'm not even gonna put, I'm gonna erase that 0 because it confuses me. But does everybody get why the initial height is 0?
Yeah.
Okay. I'm gonna get rid of that. So here is my equation for this problem, okay? A, when will the projectile's height above the ground be 768?
To plug in 768.
Plug in 768 for what?
8 for H.
For H, exactly. So part A is 768 equals negative 16t squared plus 256t. Now, you need to solve that equation, okay? So what are your thoughts on solving it? We're not gonna graph it.
0.
Quadratic.
Never mind.
Let's just get everything on the same side.
We can, let's get everything on the same side
Yeah.
first.
Sorry, let's start with that. That's a good idea.
It is good, it's a great idea.
Or there might be.
There might be a GCF. Let's just keep our fingers crossed. Does 16 go into that?
I'm afraid.
I mean, let's just try it.
Let's just try it.
Why not?
Yeah.
Yeah, 48.
Awesome.
Wow.
Dang.
So I'm gonna divide everything by negative 16. And I'm gonna end up with t squared minus 16t plus, what'd you say that was?
48.
48. Now, that's the same equation, but boy, doesn't that look better?
Yeah.
Okay. I wouldn't have done that if 16 didn't go in here evenly, because I really don't want to mess with the fraction. But I do want to get rid of the GCF anytime I can. All right, does that by any chance factor?
4 and 12.
Okay.
4 and 12.
4 and 12?
Ah, okay.
Wow, that's awesome.
Yeah.
4 and 12? So T equals 4 seconds, remember it's time, or T equals 12 seconds. Now I need somebody to explain to me if both of those answers are okay, or if something is fishy here in terms of this problem. Think about what's happening in the problem.
Smells fishy.
Smells fishy.
I smell fish.
I think it's 4 seconds.
I think it's 12.
Oh, no.
All right, so what's happened? Let's draw a picture of the problem. What happened? We got a projectile on the ground,
Yeah, it's launched straight up.
launched up. I can't draw it straight up, so I'm gonna draw it over here at a little bit of an angle like this. But it looks like that, right?
Yeah.
It goes up and comes back down,
I think it's 12.
okay?
It smells fishy though, so
I know it's 4 because it has the feet per second.
Okay, now
Joe
wait a
Garvey.
second.
Joe
Wait a
Garvey.
second.
No, garbage. It smells fishy.
We wanted to know when this thing reached 768 feet.
Yeah.
So somewhere is 768.
Yeah.
So that's
Does it
not-
make sense that there's two answers?
No.
Yeah.
Because no.
One's on the way up, and
Oh.
one's on the way
That's
down.
why it's not fishy.
It says
One's on the way up,
initial.
one's on the way down.
Wait, couldn't we just plug this into our calculator? Couldn't we just plug this into our calculator and say y equals 768 and find the intersection?
Absolutely.
I knew it. I knew it.
I know.
We can
I
use
knew
this
it.
graphic.
Straight along Johnson.
Jay, the question you're asking would be the same as, could I have done this with the quadratic formula? Sure.
Now
There are
16
lots
fish.
of ways to solve a quadratic. Okay, all right. Calm down.
It still smells fishy.
When will the project, so the answer to A is 4 seconds and 12 seconds.
It's a long time.
When will the projectile's height be at least 768?
4 seconds.
Sure. Won't it be at least 768 in that whole area?
Yeah.
Yeah.
So the answer to B, this was A, the answer to B is from 4 to 12. Now, why am I including the 4 and the 12?
Because it's up and
Because
down.
it's at least. That means it can be 4 and it can be 12.
Still there.
So will it always like throw an issue like that when there's tricky problems?
This is sufficient.
It did, because there was 2 answers.
But it makes sense that there would be 2 answers.
So a good thing.
Because the object is always going to be going up and coming down. All right. When will the projectile's height be less than or equal to 768? Less than or equal to would be all this and all this, right? So 0 to 4. Or
No, because it can't go underground, so that's why it's there.
that's my tuition.
Yeah,
That's tangled. That's like a tangled.
Somewhere
Like a
over there.
tangled cell.
12 to 0, we can't have, we can't do that. This has to be 12 to a bigger number,
Yeah.
right? This is like a number line. Okay, so it can't be 0. Although I get what you mean till here, right? Okay, now again, this is a point. The y coordinate is 0, but I don't care about the y. I need the x.
Yeah.
It's gonna be 16.
Why do you think it's gonna be 6? Who said that?
One.
Why do you think? Coleman said 16?
Yeah.
Why do you think it's gonna be 16?
I don't know.
You know, he's all red, he's up here blushing. He's right. He's right. It's 16.
Oh, no way. Wow.
What shape, guys, whoa, we are out of control. What shape is this? I didn't draw very well. This is a parabola. Parabolas are symmetric figures. So if it took me 4 seconds to get up, then it's going to take me 4 seconds to get down. Parabolas have symmetry all over the place. Right?
Yeah.
Now,
Why would the
we don't want to say 12 to infinity because it can't go underground. So it is going to stop here, right here.
Why would 16 be the Y spot when it's got
What?
Come on, it's fine.
This is X.
I know, but why is the 16 in the Y spot?
No, it's 12 to 16.
This is an inner.
Oh, yeah, I was sorry. Sorry.
So they're like just individual lines. Just like individual lines.
All right, you guys, stop it. We're ready for letter B. Letter B, number 34 from the textbook. All right, so take a second, and with your partner, this is basically the same problem. See if you can fight your way through it without my help. Okay?
Same formula?
Same formula, so I'll put that back up here. Here is your general formula. You do not have to memorize that. I will give that to you when I ask you this on the test and the semester exam. This will be a semester exam question also. It's a biggie. This is a general formula. So the first thing you're going to do is customize it for your problem. All right? Then you're going to start answering the questions.
I just use access to you.
You got plugged in at 9.
This is custom made.
Velocity, so 272.
What do we shoot? 20?
Color. Focus,
I
man.
got my custom one.
Wait, so what's Oh, yeah. Yeah, you got it right.
And then,
Yeah.
What?
no, it's what you do 20.
Yeah.
Keep mine.
Tulane, I love that. That's my NCAA. You know Tulane? How do you use that? Where?
Now, Martin, do you think I
And everything. They're always extra.
Hey, now, you working?
Yeah. I'm sorry. I'm just so.
I know you're always together. You're ever
6 and 10, 17.
You're right. I like it now.
We divided it by 16? Okay. So 2 squares.
Alright, mine's 16.
Did I even notice
Oh, you're...
Yeah.
Just stay there.
Doesn't color. 20 and 30.
17.
Yeah, we'll drop it.
And we got
Negative 20.
negative 3 is not worth
You guys, remember, if you can't factor it, you can always go back and use the quadratic formula. This one does factor. Not that way, because it won't factor.
So it's positive 20
That would be a negative 16.
Negative 3. Oh, I thought it was, the answer is negative 3.
Positive 3 there.
20 minutes.
Oh, wait, never mind, that's pog.
20 minutes.
That's pog. So negative 20 seconds, you can't do that.
Positive 20. If you have a negative,
Guys,
you're making me.
we're getting all kinds of nutty factoring here.
He's talking a lot, guys.
What was your equation? H equals negative 16 z squared.
Plus 272 minus negative 20 divided.
This was your initial equation.
Yeah.
Then you plugged in 960 over here.
960 over.
They recruited.
Move the 960
Oh,
over.
it's a negative 16. Okay, I got it.
And all of these, fortunately, are also divided by negative 16,
Yeah,
okay?
I got it.
Now, we gotta get the factoring down, you guys. You cannot just throw something down and then think it's okay. It's okay to throw something down, so some of you are doing 20 and 3.
Yeah.
Which makes sense to me, because those are gonna add up to negative 17. But they multiply to be negative 16. And you need them to multiply to be positive 60. That's not the right, those are not the right factors.
It'd be no negative.
No, you gotta use it.
Changing the signs ain't gonna help, because it's still negative 60.
God.
You have the wrong numbers.
God. It's not 10 to 6. It's not.
I was probably 5. I was probably 5.
12 and 5. There we go.
What did we say?
Now,
Wait, why would it only be 20?
if this is a test question, and you try a couple and you just can't think of, 12 and 5 doesn't pop into your head, don't sit there and waste time. Jump in and do the quadratic formula, because that will always work. It's quicker to factor, but not if you can't find the factors. So don't just sit there, jump in and do the quadratic formula. It will give you 12, and 5. So our picture, here's our parabola, here's 5, here's 12 seconds. That's when it is exactly 9:60. So question A is right here, 12 and 5. That's seconds. 12 seconds and 5 seconds. On the way up at 5, on the way down at 12. Now when will it be more than 960? More than 960 would be all of that, isn't it?
Yeah. So what would be 7?
No. The interval from 5 to 12.
No.
The interval from 5 to 12.
What is it, Kevin?
Why are these parentheses? Because it says more than. Very good, thank you for paying attention. More than. When will it be less than or equal to 960?
Under.
So 0 to 5,
Union.
union 12,
To
17. Now, that 17 has nothing to do with this 17. That 17 is because it took 5 to get up, so it's gonna take 5 to get down.
those, just like what we were doing with,
Yep, that's exactly right. Only it's two-dimensional instead of a number line, but it's exactly the same idea. Shade, skip, shade, yep. All right. Boyle's law, for a certain gas, what is the corresponding range? All right, so let's pause for a second. Take a look at Boyle's law, which is something chemistry. E equals 400 divided by Okay, you guys, please, I don't want this to be like the army. I don't want everybody, having to be completely quiet and everything. We really need to focus. I know it's Friday afternoon. I can't think of a better way to end my day, though.
Amen.
I know. So stay focused. All right, so here's the formula they give me. And they tell me that V has to be between 20 and 40. The question is, then what happens to P? If V has to be between 20 and 40, then where is P? Can you figure that out?
Yeah.
Okay.
Times by the year, 400.
what are you saying?
Well, this is my littlest V, right? My littlest V. So let's put it in. If I put in my littlest V, if I put in 20 for V, what do I get for my P? 20. Okay. Now let's do my biggest V. If I put 40 in, I get 10. All right, now wait a second. Does it make sense to you that if my littlest V gives me 20 and my biggest V gives me 10, then the V's in the middle, like a medium V, would give me a number in between 20 and 10?
Yeah.
So my range is 10 to 20. Make sure you do it in that order because we always go little big, like a number line. So if your V's are in this range, then your P's are going to have to be in this range. Okay? All right. I need everybody to get out like a regular piece of notebook paper. something that you don't mind if it gets ripped up and shredded and then all busted up. So just a regular sheet of notebook paper. Don't panic, we're not having a quiz, we're doing arts and crafts. Okay? So get out a sheet of paper.
Oh, you did not rip it first?
Uh-huh.
What's his name?
Younger. I did younger.
Okay. Okay. We got our piece of paper? Alright, here's what I want you to do now. I want you to, instead of calling it that kind of paper, you'll manage. We're going to cut, or we're not gonna cut, we're gonna rip. We're gonna rip a corner, a square, out of the corner of your paper. Don't make it like mine, make it as big or as little as you want, but just kind of make it as square as you can. And once you've got the square out, then do the same thing, same size square, on the other ones, okay? All of our corners. And it's not going to be perfect, and no one cares. Just give us the most as you can. All four, yep. Now, true story, gospel truth. When I've done, this is a very common pre-calc problem, the box problem. I've done it for years. I used to have scissors available so kids could pass around the scissors and cut, so it was nicer. Until a young man chose to cut the hair of the girl sitting in front of him.
Wow, insane. Dude, that is insane. There's no way you did that.
True story. So no more scissors.
Was it accurate?
There's no way.
Active people.
How many years?
I was down in the basement, so it was
You need to be square really good.
Wow, it's young.
before the cafeteria, the new cafeteria. Yeah. Probably like in 2000.
Did he get punished? He got like an infraction.
Okay. Now, once you have your corners ripped out, I want you to fold up these flaps. Because we are literally making a box. So see, you fold up your flaps, you got a little box like this. Okay. Now, beautiful box. Now, I want to look at Sam's box, because I need everybody to look at, here's my box, and here is Sam's box. Now, Sam and I started with exactly the same size piece of paper. How come our boxes look different? What made our boxes different? Our square size, the corner size. So, would you agree that the size of your corners is going to determine the volume of your box?
Yeah.
Do you agree with that? Okay. So, let's read question B. Leave your box on your thing so you can look at it. The problem number D says, I have a piece of paper that is 12 by 15. I don't know how big our paper was, but this one's 12 by 15. We're cutting the corners out. We don't know how big they are, so we'll call them X.
Is this on the?
This is in your notes. It's number letter D. We're constructing a box with no top. You just did that. You just built one. So now we're looking at it on the blackboard. Here's my piece of paper. Here's my corners that I cut out. Here are my flaps that I'm gonna fold up. And I have my buckles. Does that make sense to you? In terms of what you just did? Alright. What size corners should be cut out in order for the volume of the box to be 125? Alright, now let's think about this for a second. How do we find the volume of the box? What's our formula?
Length times width times height.
Length times width times height. So volume is length times width times height. Okay. Our paper was originally 15. But is the box gonna be 15? No, because why? We cut a chunk off up here and a chunk off down here. So what is our length?
15 minus x, x minus 15.
15
minus x squared.
15
Minus 2x.
minus 2x.
Okay.
15 minus 2x. We started out with 15, right? We started out with 15 and we're cutting off an x and an x. Alright, what's our width? It started out 12. 12 minus 2x. Now, what's the height of the box? When you fold these flaps up, how high is the box?
We don't know.
Oh, you know.
Yeah. 3.
Isn't it x?
It's X.
Isn't the height of the box x? Right there's the height, right? So the height is just x. Now there is your equation for the volume of the box. Now I need everybody focusing. We're almost done. Hang on. What if the paper had been 20 by 30? What would change in that equation if the paper were 20 by 30?
15, 12.
20 minus 2x,
And 30.
30 minus 2x, and x, right?
Yeah.
Every time you do this problem, that is going to be the setup, and it's just going to, you're just going to put in whatever your paper is, dimension-wise. All right? Now, the next thing I need you to think about is, tell me about x. Remember in the projectile motion problem, we said the ending point was 15 or 17 or something out here, remember? It had an end. It had an end point. The problem ended because the ball couldn't go under the ground. This one also has an end point. What can you tell me about the size of x? X is the corner now. So here's x right here. Can it be -5?
Nope.
No, whatever it is, it has to be
Positive.
positive. So x is going to be something bigger than 0.
And less than 15. Or less than 12.
You're on the right track.
It's greater than 15.
No.
No, it is not.
In between 15. It's in between 15 and 12. Or subtract.
Sam said, he's close.
X
He
is
said x has to be less than 12. It actually has to be less than 6, Sam, because the whole paper is 12. And if I'm gonna cut a chunk off both sides, I can't take 8 off both sides, I don't have enough. So 6 would be the most that I can take off. Does that make sense to you?
Oh.
Think about it. Think about the paper that you just ripped. If you're gonna take a piece off each side, it couldn't, in this case, it couldn't be bigger than 6. Agreed?
Agreed.
Yes, ma'am.
Now, I need you to write this down because we're coming back to it on Monday. We're not gonna get through the whole thing. So tell me about y. So this is x. This is where x is. Tell me about y.
Has to
What does y stand for? This is y right here.
be. It's volume.
Y is the volume. Can volume be negative?
No.
All right, so my minimum there is going to be 0.
And then
What?
12.5.
No, that's a great guess.
7.
I don't know.
Oh.
I don't know.
So 7.5.
I do know it's something big and positive, but I don't know what it is.
Hello.
All right? So, tomorrow or Monday, when we graph this will be X-min, and this will be X-max, this will be Y-min, and this will be Y-max, and we'll just take a guess. Please have that written down, because that's where we're starting. I'm not going back through all that.
Now they got me wanting to know